Hello and a warm welcome to this session on identifying the terminals and parts of three-phase AC motors. Three-phase induction motors are classified into two types: the squirrel cage induction motor and the slip ring induction motor.
At the end of this session, you will be able to
read and understand the slip ring induction motor and three-phase squirrel gauge induction motor nameplate information.
List the components of slip ring induction motor
and squirrel gauge induction motor. Conduct a continuity test on the three-phase squirrel gauge induction motor using two lamps in series method.
Recognize the terminals on three-phase slip ring and squirrel cage induction motor. This is a three-phase AC motor. This is called the nameplate of this three-phase squirrel cage induction motor. A manufacturer is a person or company that produces the motor. Trademark is a sign capable of distinguishing goods of one enterprise from another. Model number is a unique number given to each product. Type of current can either be alternating or direct current. It is AC, means alternating current. Function is a three-phase squirrel cage motor. Serial number 001. Type of connection delta. Rated voltage is the voltage in which the motor is made to operate, that is 380 volt. Rated frequency is 50 Hz. Rated power is 5.5 kilowatt. Rating class is continuous. Insulation class expresses the thermal tolerance of motor winding and it can be either B or F. Rated current is 11 by 6.4 amps. Rated speed ranges from 2900 to 2920
revolutions per minute.
Protection class is IP55. This is a three-phase slip ring induction motor. Similarly, we will also read and understand the nameplate information of a slip ring induction motor.
The difference may be observed in the nameplate, that is, function, slip ring.
Look at the parts of the squirrel cage induction motor. A squirrel cage induction motor has an end shield, bearing,
shaft,
rotor, coils, stator, frame,
terminal box,
fan and fan guard. Stator is a stationary portion of the motor and delivers a rotating magnetic field to interact with the rotor. Rotor. A rotor is a central component of the motor which rotates. Shaft. Motor shaft is fixed within the rotor and it rotates with it. Motor frame. A motor frame is the supporting structure of the motor assembly. Bearings. Bearings support the rotation of the rotor. Fan. Fan cools the motor. Wiring cover. This covers the electrical terminals of the motor. Let us now look at the parts of the slip ring induction motor.
End shield, bearing, rotor, slip ring, stator, coil, frame, fan, fan guard.
Stator is a stationary portion of the motor and delivers a rotating magnetic field to interact with the rotor. Rotor. A rotor is a central component of the motor which rotates.
Slip ring. In this rotor, slip rings and brushes are used, and because of this, the motor is known as slip ring induction motor.
Motor frame. A motor frame is the supporting structure of the motor assembly. Bearings. Bearings support the rotation of the rotor. Fan. Fan cools the motor.
Fan guard. It is used to protect the fan.
The wound rotor is wound with three-phase windings, straps or wires that are used for winding. A large number of rotor turns will increase the secondary voltage and reduce the current that flows through slip rings. Each phase of the winding is connected with the slip ring. These slip rings are insulated from the rotor shaft. Slip rings are not used for transforming power but used for adding external resistance into rotor windings. Each motor has 3 slip rings which are mounted on the shaft but insulated from the shaft. Identifying the terminals of a 3-phase squirrel cage induction motor. 2 lamps with equal voltage and wattage are taken. Identifying 3 pairs out of 6 terminals. After testing the continuity, name the identified coils as U1, V1 and W1. Connect one end of the series combination of the lamps to the terminal U1 and other end to the terminal below V1. If the lamp glows bright, the linked ends are similar ends. The similar ends are named as U1 and U2. Test in the similar way for the remaining terminals and mark them as V1, V2 and W1, W2. Identifying the terminals of 3-phase slip ring induction motor. Identify 3 terminals out of 9 terminals after testing the continuity with the help of test lamp. Name the identified coils as V1, U1 and W1. Connect one end of the series combination of the lamps to the terminal U1 and other end to the terminal below U1. Switch on the power supply and the lamp glows dim. If the lamp is off or in dim condition, then the linked ends are dissimilar ends. Connect one end of the series combination of the lamp to the terminal U1 and other end to the terminal below V1. If the lamp glows bright, the linked ends are similar ends. The similar ends are named as U1 and U2. Test in the same way for the remaining terminals and mark them as V1, V2 and W1, W2. To perform this test, ensure that the earth continuity conductor ECC is connected to the main earth electrode in the perfect continuity having resistance of less than 1 ohm and the resistance of the electrode should be less than 5 ohms. AC motor terminal box details and identification of rotor terminals. Finding rotor's 3 terminals out of 9 terminals of the AC motor with the help of test lamp. Connect probe 1 of the test lamp to any one of the 3 slip rings. Slip ring terminals are identified by placing one end of the probe at the terminal and other end at the rotor slip rings. The point where the test lamp glows, those terminals are rotor terminals. Like that, other 2 terminals are also to be checked and finally name them as K, L and M. Continuity test. Let us now check the continuity test between the winding terminals with the help of a meter. Connect meter probe 1 at U1 terminal and connect the probe 2 of the meter to rest of the terminals one by one, and it was found that the meter needle does not move. The terminals where the meters show 0, that particular winding terminal U2 is said to be okay. Like that, check rest of the windings V1, V2 and W1, W2 on the terminal box. If those respective windings show 0, the motor windings are considered open.
Recap. We now understood how to read and understand the slip ring induction motor and 3-phase squirrel cage induction motor nameplate information.
List the components of slip ring induction motor
and squirrel cage induction motor. Conduct a continuity test on the 3-phase squirrel cage induction motor using 2 lamps in series method.
Recognize the terminals on 3-phase slip ring and squirrel cage induction motor.
Hope you all enjoyed this session and understood all the concepts clearly. See you in the next session with a new concept.